What's going on, Palmeretti's? It is Friday, May 8th. Colored pages coming at you. 569, 571. Homework page 195, 196. Pause it, get those torn out. Let's knock these out. All right, we're going to actually do this one all together. So if you're watching this video, it's going to be done. And all you have to do is take a picture of it and send it to me. And if it's all correct, we're good. All right. So we're going to use talking about using appropriate tools. So we're going to mention a lot of stuff from this chapter. So look back at lessons 15, 1, 2, 3, 4, and 5. Pull those back out. All right. But we're going to talk about using the appropriate tools for, strategically to solve our problem. So Caleb is standing next to the tallest building. So Caleb's down here. He's at the vertex. Okay. He wants to determine the measure of the three angles with the vertex at the tallest building and rays on the music hall, the live theater, and the art museum. Tell what tool you would use. Explain why the measures make sense relative to each. Well, as soon as we see that we're dealing with an angle, okay, the best tool we're going to use is what? Yeah, we're going to use a protractor, okay? Okay, because we're talking angles. Bam. All right. Now we got a couple things here that we already know. Check this out. This is already what? From here to here, we already got a 90-degree angle. So from the music hall's at 90 degrees. Okay? Okay. And I think I might have just put, all right. All right. So the music hall to the art museum, I'm sorry. The art museum, that's 90 degrees. Forgive me. So from the tallest building, okay. So we got a few things we got to work out here. All right. So with our protractor, okay, come from, I measured the angle. So the music hall, all right, music hall to the art museum, okay, that's going to be 90 degrees. Bam. That takes care of that one. Now we want to go from the music hall to the art museum was 90, so the music hall to the live theater. All right, music hall to the live theater. All right, that's where we're going to pull out our protractor. Now what I want to do is I want to extend this main line right here. Goes back to our lesson earlier in the week, right? Okay, so I'm going to place my vertex in the center. I'm going to actually do it on the line right there. And that's going to cut through. Let me rotate my paper around so I can see it. Vertex, line. That's going to cut through the 50 degrees. So this guy's at 50 degrees. So if the whole thing is a 90, that leaves this as a 40. So from the music hall to the live theater, right, it's going to be 50 degrees. From the live theater to the art museum, live theater to the art museum, that's going to be the 40 degrees that we just figured out. So music hall through the tallest building to the art museum, see that right angle, 90 degrees. From the music hall to the tallest building to the live theater, 50 degrees. And then that would leave that as 40 degrees from the live theater to through the tallest building to the art museum. So they're just saying to find the angles. So you saw the right angle and you see two acute angles. All right. Could we have used a ruler to measure these angles? No, we couldn't. No. Right? The ruler gives us length and width. The protractor is what's going to give us our angle measures. Make sense? All right, pause it, review it. Remember to be a good thinker. All right, which tools can you use? Why should you use this tool to help solve the problem? Is there a different tool you could use? And am I using the tool appropriately? The key with that protractor is vertex in the center. One line goes to the 180. Figure out the other line. Remember, with these two numbers up here, that's where you have to have your knowledge of acute and obtuse, because we already know a right angle and a straight angle. Now, let's see. Ooh, make sure this is straight here. Page 570. Trevor and Holly are drawing trapezoids. Remember these blocks? Trapezoids. To make a design, they need to find the measures of the angles formed by the sides of the trapezoid and the length of each side of the trapezoid. What tools are needed to find the measure of the angles and the lengths of the sides? Well, to measure the angles, right, we're going to measure the angles. To measure the sides, we could use a ruler, right, a ruler to go all the way around it, and that's what they used here. 3 1/4 inches, 3/4 inches, 3/4 inches, 3/4 inches, and then 1 1/2 inch down here. But to measure the degrees, these angles right here, we would need to use a protractor. So a protractor and a ruler, depending on what you want. Angles, measurements, protractor. Length, width, the sides, ruler. That goes back to area, perimeter, right? Okay. Down here at the bottom, what other tools could be used to solve this problem? Why are a protractor and a ruler more appropriate? When they're saying more appropriate, they're just telling us, hey, which one is the better ones to use? Okay. If we, our pattern blocks, remember those pattern blocks we saw the other day? The tan one was, I think, 30 degrees, right? We could sit there and some of them already are known, and we could have written them out and played around with those. We could talk about those. If you want to measure for length, for the ruler, you say a yardstick, a meter stick, okay? You might say a tape measure. But for right now, ruler, protractor, okay? Angle measurements, protractor. Length, sides, width, ruler. You with me? Okay. Wow. Technology down. Technology down. We still recording? Yeah. My thing fell off the table. That's hilarious. First time all season. All right. Here we go. Haha. Sorry about that. Let's go through some guided practice and talk about this. Okay. All right. So Lee, let's see. Is this on there? Yeah. Lee bought 1 3/5 pounds of apples to the picnic. Hannah bought 4/5 pounds of oranges. Lee said they bought 2 2/5 pounds of fruit in all. Lee needs to justify that 1 3/5 plus 4/5 equals 2/5. What tool could Lee do to justify it? We could use our fraction strips, but I wasn't big on those. I'd rather you show your work, okay? Just show your work, okay? How can Lee use a tool to justify the sum? Draw pictures of it. We could draw the pictures of it, and that's fine. But what we're going to do is we're going to say 1 3/5, right, plus the 4/5, right? We would get 1 7/5. What do you notice there? Right. Well, this right here, 1 3/5 plus 4/5, we could multiply and add. 5, 12, we get 12/5. We divide that, we're going to get 2 2/5. Okay? All right, so review that one. Write that down. 1 7/5, which equals 12/5. We divide that, we get 2 2/5. Down at the bottom, what are the measures of the sides and angles of the parallelogram? So as soon as we see measure the sides and the angles, that's where our ruler is going to come into play. Now, if you have your ruler, it's right here at the end of your protractor, okay? We're going to measure this. All right, I see 1 3/4 here, so that's going to be 1 3/4. Okay, measure the top. Let's see, let me measure it a little better. I see 1 1/4, 1 1/4, 1 1/4. So we're going to use our ruler for that. Now for the angles, see where these corners are? There's your vertex. Everybody say vertices. Okay, so now what we can do is we can put a line on one, and notice how it's not going to cut through, so I want to draw one of these a little longer. I'm going to draw it a little longer. Okay, I'll watch what I do. Get my vertex here, make sure I can see it, corner there. Looks like it's cutting through. All right, now that's where I've got to figure it out. Is it the 75 or the 115? See how it's 110 and 100? 100 and between 100 and 110, between 70 80. So it's either 75 or 105. Well, what kind of angle is it? It's obtuse, so that's going to be 105 degrees. Okay. All right, 105 degrees. I'm going to write it a little better over this side. 105 degrees there. So what we'll find out is that this is 105 degrees down here because that's the same one. Now, we can do some thinking here. Take this line here. I can mark that through. That's going to be 75 degrees, 75 degrees. See that? What tools can we use? Ruler, protractor. Ruler for length, width, the sides, protractor for the angle measurements. Okay, all right. I'll explain how to use the tool to choose. All right, so with the ruler, we just measure it from the end of the ruler where it says a 0, not the end of the ruler, but right at that line. And then the protractor, we use the vertex. Okay. Explain how to use the tool to choose to find the length of the sides, label the figure with the measures. And we just knocked that out. So done, done. Put 2 checks. All right. Flip it over. All right. All right. Here we go. All right. Can you see it? Cool beans. Here we go. So this is a mural, side of a wall. They painted this picture, but she planned what she was going to paint. She sketched the diagram shown and wants to know the measure of WVX, WVX. She wants to see WVY. She wants to see XVY, YVZ. So she wants to figure out this angle, this angle, this angle, and the whole angle, right? So she wants to figure out all those angles. So there's 1, 2, 3, and then YVZ, that's 1, 2, 3, WVX, WVY, 2, XYVY. All right, so she's got all these angles she wants to figure out. So what quantities are given, okay? Well, the sum of the measures, what's this whole thing going to be? What's this whole thing going to be, right? The whole thing is going to be 180 degrees. So angle WVZ, got to look at my letters, is going to be a 180. So we know that, okay? We know that. Now, what do you need to find? Well, we need to find the other angles. Okay, we need to find the angles that she mentioned. I'm not going to rewrite all these letters. You could rewrite these letters down here, but this is one of those pages where you just want to explain it. So measure, what is the best tool to use? Our best tool to use is a protractor. Okay, best tool to use is a protractor. So let's come back up here. What I do is I extend some of these lines. Let's do that guy right there. So here's my vertex. I'm going to put a mark on there because this is the vertex we're going to use. And I want to do WVX first. And then we can write the numbers right up in there. So put that on the vertex. That cuts through the line. So that looks like it's, is it 50 or 130? Well, what kind of angle is that? It's an acute angle, right? So this guy is going to be, I'm throwing stuff around, 50 degrees. So angle WVX is 50 degrees. Now, since I marked that line through there, I can do my vertex here, go through the Y. All right, let's see. All right, what's he cutting through? 120 or 60? Well, what's this guy? An acute or an obtuse? Well, he's going to be the acute. So XVY, angle XVY is 60 degrees, right? And then we got to do the last one. What should it equal? Do I have to measure it? No, watch this. 50 plus 60 is 110. So take the 180 minus the 110, and that's going to leave angle YVZ as 70 degrees. Do we want to measure it? Let's measure it and see. I forgot to extend it, so that's my bad. All right, so I extended it. It's about 70 degrees. See that? But once we measured this 50 and this 60, put those together, we got 110. We knew the whole thing was already a 180, right? Boom, we got our last measurement. There you go. Homework page. Let's knock this one out together. You get it done with me? You don't have to turn in it. You got to send a picture. So using your appropriate tools, read through how they use this again. Let's look at it. The whole thing is a 180. So then they break it down and they can talk about each measurement and figuring it out. Just look through that. But down here, all right, it says Jason wants to set up blocks for a game. He wants to set the blocks up in a what? He wants to use an array. What do we remember about an array? It's nice and neat, like your egg carton, right? You open up that egg carton, they're laid out in 2 rows of 12 if you get 24. If you get a dozen eggs, maybe 4 rows of 3, 2 rows of 6. He wants to use between 20 and 90 blocks. How can Jason set up the blocks? What tool could Jason use? Explain how Jason could use a tool to find out one of those. So there's all kinds of different ways that he could do. He could line them all up. He could show a nice array. So he could put an array, but it's got to be between 20 and 90. It's got to be between 20 and 90. So what numbers could you have? Well, that array is going to be really nice. Could you do 4 of 4? Nope. You could do 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9. Those are all the different ways that he could do those arrays because it's between 20 and 90. 10 of 10 would be 100. 4 of 4 would be 16. Page is done. All right, flip it over. Now, Marcus created the tile pattern shown. All the angles of each hexagon have the same measure, and all the angles of each equilateral triangle have the same measure. Couple things here. All right, equilateral triangles. What word do you see in equilateral? Equal, right? The hexagon. So the hexagon, we played with that the other day, right? Each measure in that hexagon was 120 degrees. All right, each angle was 120 degrees. An equilateral triangle, all right, equilateral triangle, all right, each one of those is going to be what? Well, how many angles are there? Right. So equilateral means all the sides are the same. Okay. So that's going to be 60 degrees. Okay. So the equilateral triangle, each one is going to be 60 degrees. Because what we're going to find out is inside that triangle is 180 degrees. So what tool could you measure to measure the angles? For angles, what do we use? Protractor. Okay, we use a protractor. Okay, that's going to give you the measurement of the angles. Write and solve an equation which can be used to find the measure of one angle of a triangle. What is the measure of that angle? Okay, so the angles of the hexagon are each 120. Okay, the triangle, so a hexagon, you take that hexagon, and we could sit there and break that apart into, let me show you. Watch this. If we do this, and this, and this, see the 6 triangles? See that? Watch this. 1, 2, 3. See the 6 triangles? Okay, so that, and inside that triangle, it's going to be 60-degree angles. All right, that page is done. If you've watched this video, you checked it off, send me this page done right here. All right, and for me to know it, I want you to put a smiley face right in that corner. All right, later, you guys. Take it easy. You be good. Bye.